So hello everyone, welcome to this new video. So in my previous video I was discussing about the problems related to the inverse Laplace transform of convolution theorem, right? So we have discussed many problems. So those who have not seen it, please go and watch it. So in this session I'm going to continue with applications to solve ODEs, okay? ODE stands for ordinary differential equations, where we should be knowing the Laplace transform of the derivatives, okay? First order derivative, second order derivative, how you could be calculating it, okay? That we are going to see, okay? So in this we are going to go through it, each of the following, that is Laplace transform as well as inverse Laplace transform, okay? First let us see application to solve ODE. Here y dash, y double dash, y triple dash and y 4 dash degree are the successive derivatives. Then the Laplace transform of these derivatives is given by, first is Laplace transform of first order derivative, that is y dash. It is given by s into, since we know that Laplace transform of f of t, this is of the form f of t, is in terms of f of s, right? So s into L of y of t minus y of 0, okay? So this is for first order derivative. Similarly for second order derivative, L of y double dash, it is given by s square into Laplace transform of y of t minus s into y of 0 minus y dash of 0, okay? Similarly for third one we have Laplace transform of the third order derivative, okay? That is s cube into Laplace transform of y of t minus s square into y of 0 minus s into y dash of 0 minus y double dash of 0, okay? If the order would be increasing and the degrees also would be increasing for the term s, okay? So this is for fourth order. Fourth order they won't be asking because the problems would be very much lengthier and you won't be getting time to solve it, okay? The maximum restriction are till third order, okay? So you should be knowing first three formulas very well. So using these now, let us solve some problems, okay? The problems are very lengthier, but if you understand it, you could be easily solving it, okay? So this question again is confirmed, it would be coming for 10 marks, okay? Because this is a lengthy problem, so it would be carrying 10 marks. So let us solve some problems now. So this is the question. An ODE is given by y double dash plus 3y dash plus 2y is equal to 0. Okay, so this is one ordinary differential equation which they have given. Also, they have given that y of 0 is equal to 0, y dash of 0 is 2. So using these data, you should be finding the inverse Laplace transform by using any LT as well as ILT. It is left to you. Okay, so this is the question. Let us try to solve now. First, write the given equation, that is y double dash plus 3y dash plus 2y equal to 0. First step while solving this is apply Laplace transform on both sides, that is put LT on both sides. Okay, so this is the first step while solving these problems, that is L of y double dash plus 3y dash plus 2y is equal to Laplace transform of 0, okay? So that is equal to, split it, L of y double dash plus 3 is constant, take it outside, L of y dash plus 2 is constant, L of y is equal to Laplace transform of 0 is 0 itself, okay? So now what is L of y double dash given as, according to the applications which I have discussed right now? It is given by s square into L of y of t minus s into y of 0 minus y dash of 0, right? Plus 3 into L of y dash. So L of y dash is given by s into L of y of t minus y of 0 plus 2 into L of y. L of y, or you could be writing it as L of y of t. Okay, it is one and the same. The whole thing is equal to 0. Now s square L of y of t So what is y of 0? According to the question, it is 0, right? So this term goes. So here also y of 0 is 0. So this term goes. So y dash of 0. Y dash of 0 is 2. So minus 2. Then we have 3 into plus 3 into s into L of y of t plus 2 into L of y of t equal to 0. So wherever L of y of t is there, those terms you take it common, that is L of y of t into s square plus 3s plus 2 is minus 2 equal to 0. So L of y of t is into 3s s square plus 3s plus 2 minus 2, bring it to that side, then it would be equal to 2. So therefore our L of y of t is equal to 2 divided by s square plus 3s plus 2. Okay, so here we have solved till here. So now do the partial fraction simplification, that is the denominator part, you make it equal to L of y of t. So here I will simplify it here, that is s square plus 3s plus 2 can be written as s plus 2s plus 2, right? So that is s into s plus 1 plus 2 into s plus 1. Okay, try to find the roots here. So that is s plus 2 s plus 1. So that I am replacing it in the denominator side. So 2 divided by s plus 1 s plus 2. So now this is how the format of partial fraction. Now solve and simplify using partial fraction method, that is 2 divided by s plus 1 into s plus 2 is equal to a by s plus 1 plus b by s plus 2. So name it as equation star. So in order to cancel the denominator part, cross multiply a into s plus 2 plus b into s plus 1 divided by s plus 1 into s plus 2. So the denominator would be getting cancelled. So you would be left with 2 is equal to a into s plus 1 s plus 2 plus b into s plus 1. Okay, so in this equation you should be trying to find the value of a and b. Okay, how to find the value of a? In order to find the value of a, the b term should be equal to 0. How to make it equal to 0? Put s is equal to minus 1. Okay, that is put s is equal to minus 1. So the equation would be looking like 2 is equal to a into minus 1 plus 2 plus b into minus 1 plus 1. So minus 1 plus 1 is 0. So this term goes 2 into minus 1 plus 2. 2 minus 1 is 1. So the value of a would be equal to 2. Okay. So similarly put s is equal to, so here in order to find the value of b, we should be making a term equal to 0. So put the value of s as minus 2. So 2 is equal to a into minus 2 plus 2 plus b into minus 2 plus 1. So this would be 0. 2 is equal to minus 2 plus 1 is minus 1. So b would be equal to minus 2. Okay. So now equation star becomes L of y of t is equal to a divided by s plus 1. So the value of a is 2. So 2 divided by s plus 1 minus 2 divided by s plus 2. So now bring this L term to the other side. So if you bring this L term to the other side, it would be the inverse, right? So we need y of t. Our goal here in the application to solve ODE to find the y of t. Okay, whatever we do, right, at the end you should be finding y of t. So y of t would be equal to, if you bring L to other side, it would be inverse, L inverse of 2 by s plus 1 minus L inverse of 2 by s plus 2. Okay, so 2 is constant, take it outside. 1 by s plus 1 minus 2 L inverse of 1 by s plus 2. So that is y of t is equal to 2 into 1 by s, L inverse of 1 by s plus a is given by e to the power minus at. So in place of a we have 1 e to the power minus t minus 2 e to the power minus 2t. So y of t is equal to 2 into e to the power minus t minus e to the power minus 2t. Okay. So this is our final answer. So in this way you should be solving for applications to solve the ordinary differential equations using the Laplace transform of the similar order derivatives. Okay. So this is one simple problem. So we have one more problem. Let us solve it. So this is the second question. D square x by dt square minus 2 dx by dt plus x is equal to e to the power t. Okay. So here is the question where they have given the values of x as x is equal to 2, dx by dt is equal to minus 1 at t is equal to 0. Okay. So here the question is a bit twisted. This question also could be framed like this. That is, this could be written as second order derivative, right? D square x by dt square, that is x double dash minus 2x dash plus x is equal to e to the power t. Okay. And these data could be given as, they have given at t equal to 0. So x of 0 is equal to 2 dx by dt, that is x dash of 0 is equal to minus 1. Okay. So now the question is clear, right? So now using these data, try to solve the problem. First is apply Laplace transform on both sides. That is L of x double dash minus 2x dash plus x is equal to L of e to the power t. Okay. So we know that Laplace transform of e to the power at is given by 1 divided by s minus a. So in place of a we are having 1. So this would be equal to 1 divided by s minus 1. Okay. So write it. Before that, just split this part, that is L of x double dash. So 2 minus 2 is constant, take it outside. L of x dash plus L of x of t. Okay, x or x of t, it is one and the same. Okay, is equal to 1 by s minus 1. So L of x double dash or y double dash, here the variable is x here, so that's why it is given by s square into L of x of t minus x into x of 0 minus x dash of 0. Okay, minus 2 L of x dash is given by s into L of x of t minus x of 0 plus L of x of t is equal to 1 divided by s minus 1. Okay. Now further solve it. S square L of x of t. So x of 0 is given as 2. So minus 2s. X dash of 0 is minus 1. So minus of x dash of 0, that is plus 1. Okay. Minus 2s into L of x of t. Minus 2 into minus. So minus minus plus. And 2 into 2. X of 0 is 2, right? So 2 2s are 4. Plus L of x of t is equal to 1 by s minus 1. Okay. So now again L of x of t terms which are common, take it common, that is s square minus 2s plus 1. Okay, then we have extra minus 2s here, plus 1 plus 4, that is plus 5, is equal to 1 by s minus 1. So L of x of t into s square minus 2s plus 1 is equal to one by s minus 1 plus 2s minus 5. Okay, I've taken this minus 2s plus 5 to other side, so it would be plus 2s minus 5. So now L of x of t, s square minus 2s plus 1 is equal to 1 plus 2s minus 5. So now what I'm doing is I'm introducing s minus 1 term. Okay, one more. So L of x of t 1 plus, so multiply these terms, 2s square minus 2s minus 5s plus 5 divided by s minus 1 into s square minus 2s plus 1. Okay, L of x of t is equal to 2s square minus 2s minus 7, 5s minus 7x, 5 plus 1, 6 divided by, so here you observe here, this is of the form a minus b into a square minus 2ab plus b square. Okay, so this is equal to a minus b the whole cube. Okay, the identity, these two, this follows this pattern here, identity. So if you then if you observe here, the value is s minus 1 the whole cube. Okay, so this is our L of x of t. For this you should be applying the partial fraction and solving further. That is 2s square minus 7x plus 6 divided by s minus 1 the whole cube is equal to a divided by s minus 1, partial fraction you apply, b divided by s minus 1 the whole square, c divided by s minus 1 the whole cube. Okay, so simplify here, what we will be getting, a into s minus 1 the whole square plus b into s minus 1 plus c divided by s minus 1 the whole cube. Okay, so this would be getting cancelled, so you would be left with 2s square minus 7s plus 6 is equal to a into s minus 1 the whole square plus b into s minus 1 plus c. Okay, for this now you should be finding the values of a, b and c. So how to find the value of first let us see which values could be getting find out. If you observe here, a and b, in a and b we have common terms, so you could be finding the value of c, because if you put the value of s as plus 1, so a, b terms will be getting cancelled. Okay, so let us do that. First put s is equal to 1, so it would be 2 into 1 square minus 7 into 1 plus 6 is equal to a into 1 minus 1 the whole square plus b into 1 minus 1 plus c. So 1 minus 1 is 0, so these two terms gets cancelled. 2 into 1 square is 2 minus 7 plus 6. 2 minus 7 is minus 5. So 6 minus 5 is 1 is equal to c. So c would be equal to 1. Now if you observe carefully, we cannot find the values of b and c, because we cannot find the values of b and a, because if you want to find the value of b, we should be having some common terms between a and c, but we don't have. We have separate terms. So if in case we don't have the common terms, you should be considering the highest degree coefficients first. Okay, so first what you should be doing is highest degree coefficients in the particular question. So here highest degree is 2, so compare. So some of you might be knowing this how to do, but those who don't know, I am telling you, compare coefficients of highest degree s square, okay, in this equation. Okay. So if we compare s square coefficients, so wherever there is a coefficient for s square, that you should be mentioning in the question. So here if you observe here, we have 2s square minus 7s plus 6, where only with the coefficient of s square here in the left hand side it is 2. So mention that 2 is equal to, in this equation now, how many coefficients of s square are there, that and all you should be writing. That is, here we have a into s minus 1 the whole square. If you split this s minus 1 the whole square, it is equal to s square minus 2s plus 1, right? So if we multiply it with a, we would be getting as square, right? So the coefficient of s square is a. So that is there. And similarly here we don't have any coefficients of b and c. We don't have any coefficients of s square. Here we have s and here we don't have s term. So it would be plus 0 plus 0. So we can, after comparing the coefficients, we would be getting the value of a as 2. Similarly, one value is done. In order to find the next value, that is b, 1 degree down, that is s square is done. Next compare coefficients of s in the particular equation. Okay. So here the coefficients of s are, one is minus 7 and these two are for s square and 6. So that is one term, right? Minus 7 is equal to, so here how many coefficients of s are there? So if you split this would be s square minus 2s plus 1, right? If you multiply it with a, here it would be getting multiplied by minus 2as. It would be looking like this after multiplication, right? So now the coefficient of s here is minus 2a, right? So that you mention it here, minus 2a. Similarly, if we multiply here b into s, so it would be bs, the coefficient of s is b. Okay, and for c we don't have any coefficient, so minus 7 is equal to minus 2a plus b. So a value we have got it here, substitute that, minus 2 into 2 plus b, so minus 7 is equal to minus 4 plus b, so b is equal to minus 7, minus 4 you bring it to other side, plus 4, so b is equal to minus 3. Okay, so like this we got the values of a, b and c. Now put it in the equation star, that is 2s square minus 7s plus 6 divided by s minus 1 the whole cube is equal to 2 divided by, the value of a is 2, right? 2 divided by s minus 1. The value of b is minus 3 divided by s minus 1 the whole square. The value of c is plus 1 divided by s minus 1 the whole cube. Okay. Now take the Laplace transform. L of x of t is equal to this term. So if you want to find only x of t, then you should be taking Laplace transform. On other side, that would be inverse Laplace transform, right? So L inverse of 2 by s minus 1 minus 3 is constant. L inverse of 1 by s minus 1 the whole square plus L inverse of 1 by s minus 1 the whole cube. Okay. So x of t is equal to 2 into L inverse of 1 by s minus a. Okay, it is given by e to the power t, right? So the value of a is 1, so e to the power t. And here we have s minus 1 the whole square. First what I am doing is, I am taking the separate inverse Laplace transform of 1 by s minus 1. Okay, if we take L inverse of 1 by s minus 1, that is equal to e to the power t. So minus 3 e to the power t I am writing here outside. Then L inverse of the remaining term, that is 1 by, since we have s minus 1 the whole square, so we have taken its inverse Laplace transform, written it outside, so we are left with s square. Okay. Similarly here 1 by s minus 1, that is again e to the power t, L inverse of 1 by s cube. Okay. So that is x of t is equal to 2 e to the power t minus 1 by s square. 1 by s square is L inverse of 1 by s to the power n plus 1, that is t to the power n by n factorial. So here 1 degree would be down, that is t to the power 1 by 1 factorial, that is 3t e to the power t. Okay, plus 1 by s cube is given by L inverse of 1 by s cube is t square by 2 factorial. So that is t square e to the power t divided by 2 factorial, that is 2. Okay. So this would be our final answer. Okay. So in this way we should be solving. So these were the two important problems, guys. So hope you understood something from this. And please note down these problems. These problems are very, very important. So if time permits, I have some more problems if time permits, I'll do it. Otherwise, this is the end of the module. Okay. So with this, we have covered all the concepts of this module. So we could be saying that module 3 is also completed. Okay. So 3 modules we have covered till now. So please watch all the modules very carefully. All the videos in detail I have explained. So please go through it. And if you are liking our comments, if you are liking our content, so please comment down your prestigious opinions and let us know how you are able to understand these videos. Okay. So like this video, subscribe to our channel, share these videos to a huge number, guys. Thank you.